Hello there and welcome to a short video on using the serial monitor and the serial output with sketch code for the Arduino Uno or the Heist board. This is brought to you on behalf of the Heist, which is an interactive escape room style game where you learn electronics and coding at the same time, and it's brought to you by Enigmail. Do have a look at our website if you like, but for the moment let's have a look at how brilliant the serial monitor is. So with any code sketch, you can do several things at the same time. Obviously, they happen sequentially. It goes through the code one line at a time until it hits a loop, and it follows the loop instruction. But what you can do is you can have various inputs and various outputs, and one of those outputs is actually to the computer itself, and that goes via the compiler. So I've got here on my screen the compiler. I've got a whole load of code, and I'm just going to draw your attention to just one section which I think is really important. It's this one, and it says start serial communication, and it goes Serial.begin 9600. Now this is the baud rate, BAUD, and it's really important that when you're getting your serial output that you're on the right baud rate. And what we've got then is we've got instructions that will print onto the screen. How could this be useful, you might be wondering? Well, it is honestly the best way of getting absolute feedback on whether an LED should be going on or not, whether a motor should be turning or not, or even what degree the servo motor should be pointing at, because it can give you all that information in text form, and then you can compare it to your real life board and see if it's happening or not. And if it's not happening, then you know that the problem isn't with the code but with the board itself. Very often, and I have to put my hands up and say 90% of the time perhaps, I've got the pins in the wrong location, or one of the pins has come out as I've moved the board across. So breadboards are absolutely fantastic the vast majority of the time for quick and simple building of circuits, but the pins can come out, and you can sometimes change the number on the board and get the wrong pin, and then the system won't work at all. So what I'm going to do is going to demonstrate the output. So I'm just going to upload this code. It's going to verify it, make sure it's okay. So it's compiling it and checking it. It's happy with that. And then I'm going to send it across. So it's going to upload it, and it's attached. Now, if we float over to, we've got outputs at the moment, but that's just telling us what it's doing at the moment. If I float over to this icon here, which says serial monitor, what this does is it tells me exactly what's going on with the board and the code of the board. And it's telling me at the moment that it's in mode 0, the default state of the LED is off. Now, this particular code demonstrates the different states that you can have, the different logic states. So the AND state, the OR state, the XOR state, the NAND state. For those of you who've got the Heist kit, this is unit 14 that I'm demonstrating here. And if you know, or you can recall me talking about the baud rate, it's still highlighted in the code here. You can see the baud rate is here. I can change that to 300, and now I'm just getting garbage. So it's a quick way of coding things, I suspect. You can see the same pattern coming up each time, but it cannot understand. So if you get some serial monitor feedback like that, do check that your baud rate is correct. So what was it, 9600, we're back on. Now, on my little display board here, on my Heist board, I'm just going to press the button. You'll see it has changed. And it's changed so it recognises that I'm on mode 1, mode 2, and it tells me even what gate I'm in. So it tells me the state that it's operating under at the moment. Change it through. It's also telling me whether the LED is on or off. So I can press the buttons and I can actually turn the LED on or off, and I'm getting that feedback straight away. Now, if you're having a problem with your code and for some reason the sketch isn't working as you would hope, so it's saying I'm pressing the button and the LED should be going on, but the LED is not going on, you know from this that the code isn't wrong because it's explaining that the LED should be on when I'm pressing that button. So you have to go back and identify, and it's probably the LED, in all honesty, because it's recognizing that the button is working. The reason I love the serial monitor is that it's like a friend by your side, indicating where you're making mistakes or where mistakes could be made. So it's immediate feedback, and it's telling you, look, LED should be on. So if your LED isn't on in real life, you know where to look because it should be on. The code says it should be working. It's really effective. It's quite fun to play around with, very easy to code. If we look at the code, it's actually explaining exactly what to do each time. Everything's in speech marks, so you can change the language. So I could change that if this was for a cow, let's say, completely random. I've added loads of those, and then you can see because I've opened it up, I've got serial monitor there. I'm going to change the mode to the mood, and there we've got mood. So it's immediate, and you can cut and paste this and play around with it in any way you wish to. Really powerful, really effective, and very effective, really, really effective for finding errors. So if you are stuck in a quagmire and the board isn't working as you'd hope, look at a serial piece of sketch or add in some serial output. Have a look at how it's built. You just have to add it here to initialize it in the serial communication before the loop, and then see if you can find the mistakes therein. Enjoy.